Just a century ago, humanity's grasp of the universe was remarkably limited. The prevailing belief among astronomers was that all of creation existed solely within the boundaries of our own Milky Way galaxy. However, this assumption was dramatically overturned in 1928 when Edwin Hubble, through precise measurements, revealed that the universe was not static, it was expanding. This discovery fundamentally changed our understanding of the cosmos, opening the door to a new and dynamic vision of the universe's structure and history. Fast forward to 1997, when observations made by the Hubble Space Telescope uncovered something even more astonishing. It was found that the universe's expansion was not slowing down as previously thought. Instead, it was accelerating. This unexpected acceleration was attributed to a mysterious force now known as dark energy. This revelation reshaped cosmology and led to the widely accepted estimate that the universe is approximately 13.8 billion years old. However, more recent findings from the James Webb Space Telescope are beginning to challenge this timeline, prompting scientists to re-evaluate some of their most fundamental assumptions. Deep within the Milky Way lies a dense and ancient globular star cluster known as M92. What makes this cluster particularly perplexing is its estimated age. Scientists believe it to be as old as the universe itself, around 13.8 billion years. Some models even suggest it could be older. This notion is baffling, as it contradicts the logical premise that stars cannot predate the universe that gave rise to them. Yet, data from M92 appears to defy this logic and casts doubt on long-held cosmological assumptions. To determine the age of M92, astronomers employed sophisticated simulation techniques, analyzing over 20,000 synthetic stellar populations. The outcome pointed to an age alarmingly close to the universe's supposed origin, raising a profound question: have we been wrong about the age of the universe all along? Enter the James Webb Space Telescope, the most advanced observational tool ever constructed for exploring the cosmos. It has looked deeper into space and further back in time than any previous instrument, revealing galaxies that existed a mere 300 million years after the Big Bang. However, these galaxies appear far more developed and massive than expected for their age. This discrepancy suggests that either our models of early galaxy formation are flawed, or the universe itself might be significantly older than we currently believe. This leads to a bold new hypothesis. What if the universe isn't 13.8 billion years old but much older? A recent study has proposed an alternative age of 26.7 billion years. This radical theory challenges current ideas about cosmic expansion and the formation of the first stars and galaxies, suggesting that our understanding of these processes may be incomplete or even fundamentally incorrect. The existence of objects like the so-called Methuselah stars, celestial bodies that appear to be older than the universe, and the mature galaxies observed by Webb seem to support this possibility. This debate over the universe's age is not just academic. If our cosmic timeline is inaccurate, it could have far-reaching implications for how we understand life and existence itself. For instance, one of the most puzzling stellar anomalies lies in our own galactic neighborhood, the Methuselah star, officially designated HD 14283. Based on current measurements, this star is estimated to be about 14.5 billion years old, nearly a billion years older than the universe, according to standard cosmological models. Stars have predictable life cycles influenced by their mass and composition, yet this star appears to contradict those patterns, suggesting it has aged more slowly than the universe around it. The Methuselah star represents more than just an anomaly. It highlights profound gaps in our understanding of the cosmos. At the center of the age controversy lies a crucial metric known as the Hubble constant, which describes the rate at which the universe is expanding. But there's a problem. This value refuses to reconcile across different measurement methods. Observations of the early universe, particularly from the cosmic microwave background, suggest an expansion rate of about 68 kilometers per second per megaparsec. In contrast, measurements based on nearby stars and galaxies yield a higher value, around 73 kilometers per second per megaparsec. This inconsistency, known as the Hubble tension, raises serious doubts about our ability to accurately determine the universe's age. Perhaps the discrepancy is a signal that our physics is incomplete. Could unknown forces or a more dynamic form of dark energy be at work? One of the James Webb Space Telescope's most groundbreaking capabilities is its ability to peer into the so-called dark ages, a period before the formation of the first stars. What Webb has uncovered in this era is astonishing. Galaxies with masses and structures comparable to that of the Milky Way, appearing just 300 million years after the Big Bang. According to current models, such galaxies should have taken billions of years to form. This contradiction challenges the completeness of the Big Bang theory itself. As evidence accumulates suggesting the universe could be significantly older than 13.8 billion years, some scientists are turning toward even more radical concepts like the multiverse. What if our universe is just one of many, each with its own age, history, and physical laws? Within such a framework, seemingly impossible phenomena like ancient stars or overly mature galaxies could be entirely plausible. The multiverse hypothesis opens the possibility that what we perceive as contradictions may in fact be signs of interactions or overlaps with other universes. If this idea holds merit, the implications would extend far beyond astronomy. It would challenge the very foundations of reality and suggest that what we observe is only a fraction of a much larger and more complex existence. Interestingly, as James Webb continues to reshape our understanding of cosmic history, a long-forgotten theory has re-emerged, the concept of a cyclic universe. This theory proposes that the universe has not simply existed for 13.8 billion years, but has undergone countless cycles of expansion and contraction, big bangs followed by big crunches. Could the ancient stars and galaxies seen by Webb be remnants of a previous cycle? If so, they might contain clues about a universe that predates our own. Another enigma uncovered by Webb is the potential existence of primordial black holes, dense, compact objects believed to have formed shortly after the Big Bang. These entities could offer an explanation for the rapid emergence of massive galaxies by serving as gravitational centers that accelerated their formation. However, their presence also raises disturbing questions. What other aspects of the early universe have we misunderstood or completely overlooked? Dark energy, the enigmatic force responsible for accelerating the universe's expansion, may also play a more complex role than previously thought. Recent studies indicate that dark energy might not be a fixed constant, but could evolve over time, thereby influencing the universe's expansion rate in ways that conflict with current models. If dark energy has indeed changed throughout cosmic history, it might explain both the swift formation of galaxies and the puzzling contradictions in the universe's age. At the smallest scales where quantum mechanics dominates, the nature of time itself begins to blur. Some quantum theories propose that the early universe may have experienced extreme fluctuations capable of creating entire galaxies or even altering the flow of time. From the time dilation effects near black holes to the quantum mechanics at the heart of the Big Bang, Webb's discoveries are compelling us to face some of the most profound and unresolved questions in modern science. The James Webb Space Telescope has not only deepened our view of the cosmos, but has also introduced serious doubts about the foundational principles of modern cosmology. From stars that appear older than the universe to unexpectedly massive galaxies formed in its infancy, the evidence continues to build. It may soon be necessary to rewrite the cosmic narrative we've come to accept. Yet this endeavor is about more than just numbers or history. It's about uncovering the full story of existence. With every new observation, the telescope reveals the vastness of the unknown and the extraordinary scope of human curiosity. What if the universe is not 13.8 billion years old? What if it is 26.7 billion, or perhaps even timeless? What if our universe is merely a single chapter in a much larger multiversal epic? One thing is clear. The James Webb Space Telescope is far more than a scientific instrument. It is a portal through time, a narrator of cosmic history, and a key to the mysteries of reality itself. With each image it returns, it pushes us to rethink, to wonder, and to explore further into the unknown.